For 60 years, humanity has been locked in a brutal, unrelenting war against gravity. And for all that time, our only weapon has been fire. We build these towering metal monoliths, fill them with millions of tons of highly volatile chemicals, strike a match, and basically cross our fingers. We just hope that the controlled inferno is powerful enough to nudge a tiny, fragile payload into the cold, silent vacuum of orbit. It's violent, it's dangerous, and quite frankly, it's an incredibly inefficient way to travel. But what if we just stopped? What if we stopped fighting gravity with fire? Right now, while the West is laser focused on perfecting reusable, liquid-fueled chemical rockets, a new superpower is quietly rewriting the physical laws of space access. They're deploying a mysterious, highly advanced strategy that trades explosive chemical thrust for pure, silent, magnetic power. To really grasp why this shift is happening, you have to understand the main villain of our story, the tyranny of the rocket equation. It's a brutal, unforgiving physical law. It basically dictates that to carry more payload, you need more fuel. But of course, fuel is heavy, so you need even more fuel just to lift the fuel you just added. It is a vicious, inescapable cycle. Because of this mathematical tyranny, up to 90% of a traditional rocket's mass sitting on the launch pad is nothing but the propellant needed to get off the ground. The actual cargo? That's almost an afterthought. Just look at this headline for a moment from South China Morning Post. This is the news behind today's video. Will China build an electric rocket launch pad on the roof of the world? China's electric launch technology stems from a 2-decade-old idea and could potentially make SpaceX's chemical rockets obsolete. With that said, let's go straight to the intro. The algorithm buries channels that show the truth like mine every single day. The only thing that fights back is you. One like, one subscribe, turn on the bell icon. That's how the truth about China survives on YouTube. Don't let it disappear. Thank you very much. Now here's the thing. This isn't some distant science fiction concept for the 22nd century. This is an engineering reality happening right now at a terrifyingly aggressive pace. Look at the timeline for electromagnetic launch. In March of 2026, the Xi'an Institute runs their high-temperature superconducting navigation test. By December 2028, Galactic Energy Series 2 is slated to become the world's first operational electromagnetic launch rocket. By 2030, a lunar landing, and by 2035, the routine management of commercial flights. In the aerospace world, where progress is usually measured in decades, this is a staggering, immediate paradigm shift. So let's move to Section 2, the high altitude advantage and claiming the roof of the world. When you get up to an elevation of over 4,000 meters on the Qinghai-Tibet Plateau, the rules of aerodynamics fundamentally change. According to the data, atmospheric density at this extreme altitude is 40% lower than it is at sea level. That means any vehicle launching from this height faces nearly half the air resistance and half the brutal thermal friction. By moving the launch pad up into the mountains, engineers are completely solving the thick, soupy atmosphere problem that historically cripples traditional rockets during their critical initial ascent. And when you combine that extreme altitude with electromagnetic power, you get what's called a zero-stage booster. Imagine this. A massive magnetic track hurling a rocket to supersonic speeds up to Mach 3 entirely on the ground before a single drop of fuel is even burned. Once the vehicle finally leaves the track and ignites its engines in that impossibly thin mountain air, it experiences a drastically reduced maximum dynamic pressure. It's a ground-based kinetic energy transfer so massive, it literally doubles a rocket's payload capacity. This brings us to a stark, undeniable contrast in global space strategies. The chemical approach, which we see a lot in the Western private sector, focuses almost entirely on the vehicle itself, making the first stage rocket land back on a pad so it can be refueled and reflown. But the electromagnetic launch approach flips that script completely. It relies on fixed, reusable ground infrastructure to provide that initial escape velocity, completely ditching those massive first-stage liquid fuel requirements. The heavy engine of spaceflight is literally moving from the vehicle down to the ground, and the economic disruption here is absolutely massive. Usually, launching a kilogram of cargo into orbit via traditional rockets costs thousands of dollars. But because a zero-stage booster runs on electricity instead of highly refined, intensely handled liquid chemicals, the marginal cost of the energy required just plummets. We are looking at a marginal energy cost of less than $1 per kilogram to reach orbit. That doesn't just upgrade space travel, it transforms it from an artisanal explosive craft into a high-throughput electrified global logistics network. Which brings us to Section 3, surviving high G-forces and the engineering of extreme acceleration. Because as you might guess, accelerating to supersonic speeds entirely on the ground generates some immense, brutal physical forces. According to published models, reaching launch velocity over a 100-kilometer track subjects a vehicle to an average of 30 Gs of force. Now, the absolute limit for a human passenger is only 2 to 3 Gs. 30 Gs, that is instantly, unmistakably lethal to a human being. To make this safe for people, you need a track 1,000 kilometers long. So while passenger travel might be a far future dream, this brutal acceleration is absolutely perfect right now for blasting heavy cargo and raw materials into orbit. But you're probably wondering, can a complex multi-million-dollar satellite actually survive 30 Gs of crushing force? Well, yes, they absolutely can. Standard satellite electronics, when properly modified and ruggedized, have an astonishing survivability limit of approximately 2,500 Gs. So the 30 Gs generated by a cargo truck barely even registers against the safety margins of properly hardened electronics. It is a completely solved engineering problem. The material science making all this possible is basically an orchestra of extreme engineering. To generate these incredibly strong, stable magnetic fields, the system uses high-temperature superconductors, specifically a compound known as YBCO, that has to be continuously bathed in liquid nitrogen. And the vehicles themselves? They use 3D printed high-thrust components capable of withstanding immense mechanical shear, specialized domestic stainless steel for deep structural support, and heavy ablative thermal protection just to survive the sudden violent friction of hitting mountain air at Mach 3. Moving into Section 4, lunar mass drivers and the strategic frontier. Now, if electromagnetic launch is highly efficient here on Earth, it is an absolute cheat code on the moon. Because the lunar surface has a fraction of Earth's gravity and precisely zero atmosphere, a launcher there doesn't have to fight any aerodynamic drag or stagnation heating whatsoever. Recent aerospace projections estimate that a mass driver system on the lunar surface would operate at a stunning 10% of the cost of conventional Earth rockets. It paves the way for continuously, uninterruptedly launching mined lunar resources like water ice and rare earth metals directly into orbit. However, an impartial reading of the strategic sources reveals some profound dual-use military applications here. A sustained lunar mass driver is far more than just a scientific tool for mining. Because these launchers operate silently and entirely outside traditional terrestrial early warning networks, defense analysts note they could act as undetectable first-strike platforms. They actually have the capability to launch what are called kinetic energy impactors, inert, high-mass projectiles traveling at devastating speeds that would be nearly impossible to intercept from Earth. And this is exactly why researchers describe these systems as unparalleled sources of space power. Dominating this lunar infrastructure means a lot more than just visiting the moon to plant a flag and take a photograph. It means establishing a permanent, sustained logistics chain. It means effectively controlling the astrography, the strategic geography, and the physical high ground of the entire Earth-Moon system for centuries to come. Which brings us to our final section. Section 5, the next space era and claiming the future. We are witnessing a truly monumental shift in how humanity approaches the cosmos. So I want to turn this over to you. Look at the data we've covered, the timelines, the physics. Is electromagnetic launch the final nail in the coffin for traditional rockets? Will the violent, explosive fire of the 20th century be replaced entirely by the silent, relentless magnetism of the 21st? Take a moment, process the implications, and let us know your thoughts in the comments. Thank you so much for joining me on this explainer. If you value this kind of clear, direct, and structured deep dive into the technologies shaping our world, please make sure to subscribe. We are dedicated to breaking down the most complex topics directly from the sources, without the visual distractions, so you can learn efficiently. Keep learning, keep questioning, And goodbye for now.